Hello friends, today we'll see this question. This question is from the chapter Linear Programming Problems, and this question is being asked in the year 2020 maths. Okay, so this question contains 4 marks, so let's discuss this problem. This question says a furniture trader deals in 2 items, chairs and tables. He has rupees 50,000 to invest. Okay, so the amount that he can invest maximum is 50,000. Okay, or anything less than that. A space to store at most 35 items. That means they can like store a maximum of chairs and tables which can add up to like 35. Okay, the maximum 35, not more than that. And a chair costs rupees 1000 while a table costs him rupees 2000. So the furniture trader earns a profit of 150 on a chair and 250 on a table. Okay, so formulate the above problem as a linear programming problem. Okay, LPP stands for linear programming problem, to maximize the profit and solve it graphically. So to solve this problem, first of all we'll make a table. Okay, when we'll make a table, then formulating the LPP will be very easy with the help of that particular table. Okay, so let's try to make a table. So this table we can make it like, we can first of all write a chair and a table over here. Okay, and then we can write the cost of these. Okay, one of these basically, and then we can write the profit. Okay, profit of these. Since one chair costs rupees 1000, so we'll put 1000 over here. Okay, cost of one chair, and one table costs rupees 2000, so we will put a 2000 in the table. Okay, in front of the table and in front of this cost. Okay, so this is the cost of one table. Okay, and now the profit on a chair, as it's already given the question, is rupees 150, so I'll put 150 over there, and the profit on a table is rupees 250, so we'll put in now over there. Okay, and we'll assume that the number of chairs the trader is having is like X. Okay, and the number of tables the trader is having is Y. So the first equation or the first constraint that we can have is like the number of chair and the table, they can be at most 35. So when we say at most, that means it should be less than or equals to 35. Okay, and then it says that one chair cost him rupees 1000. So if this X and Y represent the number of chairs and the number of tables. Okay, so we say we can add up here first, let X chairs and Y tables. Okay, Y tables, okay, be sold by. So we assume that X chairs and Y tables are being sold by the trader. Okay, so the first constraint that we have is, first constraint basically means those conditions on which the profit or the cost depends. Okay, like the conditions. Okay, so there's a constraint, those constraints in terms of this LPP. So X plus Y should be less than or equals to 35. This is the first constraint, and the second constraint will be like, since one chair is like for 1000 rupees, so two chairs will be for 2 times 1000, so 3 chairs will be 3 times rupees 1000. So if we have X chairs, so that will be like X times 1000, so that will be like 1000 X. Okay, X times 1000 is 1000 X. Similarly, we can say one table costs rupees 2000, so 2 tables will be 2 times 2000, 3 tables will be 3 times 3000, my bad, 3 times 2000. Okay, and so Y tables will be Y times 2000. Okay, so Y times 2000 will be 2000 Y. So if we add them together, so this is the total cost or total money that is going to be the investment for the trader. Okay, so the maximum he can invest is rupees 50,000. So maximum is this, that means he can always invest 50,000 or less than it. Okay, less than it, so we have to put here less than equals to. Okay, so that is the second constraint, 100,000 X plus 20,000 2000 Y is equals to less than 50,000. This is the second constraint, and we also know that it's like, since the number of chairs and number of tables have to be positive, so X and Y both has to be always greater than or equals to 0. Okay, more or less, before we move on to the objective function, we can simplify this constraint. We can simplify this constraint by, like, if we suppose take a common factor from both the sides as 1000, so we can write this thing as 1000 as a common factor from the left side first of all. So this is x plus 2y, okay, and then less than equals to, this thing can be written as 1000 times 50, okay. So if we can now cancel out the 1000 from both sides, so that means we can say this is like, since if we divide by 1000 on both sides, okay, so like we can do this, like, you know, like if we divide by 1000 on both sides, sorry, if we divide by 1000 on both sides, okay, dividing by a positive value on both sides does not affect the symbol of inequality, okay. So this is like x plus 2y will be less than equals to 50, okay. So this is the simplified form of this constraint, okay. So we have the set of constraints, like, so we can write the constraints as, the first constraint is like x plus y less than equals 35, and second constraint is now x plus 2y has to be less than equals to 50, and always x has to be greater than equals to 0 and y has to be greater than equals to 0, because the number of the chair, the number of the tables cannot be negative, okay. They can be 0, means no chairs or no tables, but they cannot be ever negative. Now the next thing is, we know that this is given over here, that the profit on one chair is 150 and the profit on a table is rupees 250. So we know that this thing we can use to form the objective function, and the objective function will represent the profit in this case, okay, and we have to maximize this profit. So generally or conventionally we use the capital Z or capital Z to represent the objective function. So since 150 rupees is the profit on one chair, so we can say that two chairs, or on two chairs the profit will be 2 times 150, on three chairs the profit will be 3 times 150. Similarly for x chairs the profit will be 150 times x, okay. So we can write here 150 times x first of all, and then we can say the profit on one table is rupees 250, similarly, okay, then it's given over here, okay, the profit on one table is rupees 250, so the profit on two tables will be 250 times 2, and the profit on three tables will be 250 times 3. So we can say that the profit on y tables will be 250 times y, which is 250y. So for the total profit we have to add these two, and since we have to find like what can be the maximum, we have to maximize the profit. So objective function is the profit only, so we have to use capital Z to represent this, okay. So this is the objective function which represents profit, okay. We can say profit comma, and this is the objective function, okay. So we can write this over here in the bottom, okay. On the top of this we can write here constraints, and here we can write profit, you know, and use the letter Z or the Z. So this is 150x plus 250y. So this is now the linear programming problem, and we have formulated it, okay. So now we need to graph it and solve it, because we have to solve it graphically as is instructed. So to solve it graphically, first of all let's try to plot these constraints, okay. So we have the xy plane over here, okay, and we have to draw this constraint. So for the first constraint, let's say for the first constraint, which is x plus y less than equals 35, first of all we have to draw the line x plus y equals 35. You know, the x plus y equals to 35. For this line we have to like plot when x is 0 y is 35, and when y is 0 x is 35. So we have to mark like these 2 points, 35 0 and 0 35 over here, okay, and then join it by a line, solid line, okay, basically. So this is the line which represents, okay, this is the line which represents x plus y equals 35. Now this line divides this region into two planes, okay, this side and the other side, okay, the two sides, because any line divides any plane in two parts, and this inequality will be represented by one of the regions, okay, either the above one or the below one. So to find that, what we do is actually we have to, like, this is less than equals to, so this is the lower part, okay, this is the lower part. And always remember, this x greater than equals to 0, y greater than equals to 0, this always represents the first quadrant, okay, this represents quadrant 1, okay, quadrant 1. So that means when we graph this region below this means when the graph the region below this, we have to, like, graph it in such a way that we are just in quadrant 1, okay, because that's the common region, okay. In the quadrant 1, whatever these two regions have in common should be in quadrant 1 only, then that will be the common to all of these, okay, you know. So we are in quadrant 1, or okay, yeah. So instead of shading it all, we just, like, make a symbol, okay, like this, you know, which indicates the bottom region. And how can we be 100% sure that this is the region that we need for this particular inequality? So if we put the origins coordinate in this one, which is 0, x as 0, y is 0, so 0 plus 0 is 0 less than 35, which is true, you know. If you put any other point, like suppose 10 comma 10 in this one, so 10 plus 10 is 20, 20 less than equals 35, that is true. Similarly, if you put any point, like suppose 0 comma 20, that's also good, or 25 comma 0, that's also good, okay. So if you put any point, then that will be good. Oh, I just noticed that I draw this line over here, and this line you see is, like, passing through 35 0 and 0 25, so that's my mistake, okay. So let me just correct it, okay, fine. Let me just rectify this thing. So this point is going to be there, 35 0. I don't know why I did that. Sorry. So this is 35 0 and this is 0 35, okay. Now we have to join this by line, so this is the line, okay, and the region is below this, so we have to, now we have the other inequality, x plus 2y less than equals to 50. So we can draw it, like, we can mark the point on the x when x is 0 for this one, when x is 0, so y is 25, because 2 times 25 is 0, okay. So this point over here, and when y is 0, so x is 50, okay. So let me use different color so that we can differentiate easily, okay. So let me use, like, I think this color is good, yeah. So this is 0 25 and 50 is 0, okay. Now we have to join this by line, so when we join this by line, so this is like this, okay, and this is also less than equals to, and when we check it, like, these points which are below this, I feel, so this should satisfy it, okay, because this is less than equals to means the lower part, okay. So we put 0 0 in this one, so 0 plus 2 times 0, which is 0 plus 0, okay, 2 times 0 is 0 only, so 0 plus 0 less than 50, that is good. And similarly, you can put any other point, like 0 20 or 40 0 or 15 5, anything, okay, which is in this region. You will see that this will satisfy this inequality, okay. That means this is the region is the below region, okay, bottom region. Now we understand that the common region is this two, like this, the bottom region for this one and the bottom region for this one, and in the first quadrant, so we can notice that the common region in all of these is this region, is the region which is this one, okay, which I'm shading right now. You see, this is the common region in all of these, okay. So this is the common region, so we can draw its end points, okay. We can draw, like, we can shade the polygon which is the common polygon of the common region. So if we do it like, so, or let me use marker, basically I can use yellow. So this is the common region, okay, this is the boundary of the common region, okay, and this is the closed common region, which makes our work easy, okay, because sometimes there can be open common region also, okay. So now we see these are the end points, okay, these are the end points of the common region, this and this, the 4 end points, okay. When we say it as the corner points, okay. So what are the corner points? We mark it over here, okay. We can write it over here, corner points. So corner points as the x and the y. So the first corner point, let's say this is A, this is B, this is C, and this is D. So the first corner point is 0 0, and then we can say other corner point which is B is like x is 35, y is 0, okay. And then the next corner point C, which if you can notice that x is 20 and y is 25, okay. X is 20 and the y is 25, but we have to solve it algebraically because we cannot be sure 100% because as the graph is not purely up to scale. Okay, so since this equation is x plus y equals to 35 and this equation is x plus 2y is 50, so x plus y, let's do it in the bottom. Okay, x plus y equals to 35 and x plus 2y is equals to 50. So when you subtract it, you know this equation, so this is like minus y is equal to minus 15. Okay, so y equals to 15 we have. So now when you put y equals to 15 in this equation, x plus y equals to 35, so we have x plus 15 is equals to 35, so x equals to 20. Okay, so x equals to 20 and y equals to 15, this is the point of the intersection of those two lines. Okay, oh sorry, I think I made mistake again, sorry. X is 20, y is 15, that is good. Okay, so this is the point C which was looking approximately, I don't know why I took 25 there. So x is 20, y is 15, and the final point D over here would be like D is the point you see, which is x is like 25, no, x is 0, y is 25. Okay, so x is 0, y is 25. And now we for right here our objective function, which is 150x, if I'm not mistaken, plus 250y. Okay, and we have to evaluate the value of this objective function at every corner point. Okay, one by one. So when we check the let me just verify the objective function. This is good, 150x plus 250y. So now when we evaluate this thing like 150x plus is this expression's value for each corner point, that is what we need. So for this one we know 150 times 0, what, x is 0, y is 0, this is like 0 only, so no need, but we just did because this is one of the corner points. Okay, now when we check it, like when x is 35, okay, and y is 0, so 250 times 0, which is like 15 times 5 is 75, and 15 times 45 plus 7 is 52, 5250. Okay, and now we check it for when x is 20 and y is 15. Okay, plus this is going to be like this is equal to 6750. Okay, now finally we have this objective function. So this is a corner point for which we have to evaluate this expression function. This is 150 times x is 0 over here, so this is the x6250. Okay, this is this thing. So now we see of all this for all these corner points, the maximum value of this objective function is when the x is 15 and the y is, my bad, when x is 20 and the y is 15, which means that the maximum profit will only be when 20 chairs and 15 tables are sold. Okay, so this is how we maximize it. You see, x represents the number of chairs over here and y represents the number of tables. So we can say maximum profit is, we can say the maximum, this is the maximum value. Okay, so we can say maximum profit is 6750 when 20 chairs, okay, which represents the x, okay, and 15 tables are sold. So this is how we do such a problem. Okay, I hope this problem is helpful for you. If you have any doubts, you can put your comments in this comment section. Okay, and thank you.